I'm Aaron Davidson. This segment is about external ballistics. Now, fortunately for us, we're going to calculate our external ballistics with a ballistics program. So we just need to be familiar with the input terms and the calculated outputs. We're looking for the calculation of the drop of our bullet and the calculation of the wind deflection. Now, when we look at the inputs of a ballistic program, we're looking for the muzzle velocity. We're also looking for the bullet's ballistic coefficient value. Finally, we're looking for the air density. Now, let's start with the muzzle velocity. Now, just because the manual gives you a number doesn't mean that your rifle will behave the same. You have a lot of variables. The question is, with a chronograph, do we get the actual number for our muzzle velocity? And in some ways, you can say yes, you do get your number. But even a chronograph has some errors. So we need to understand where some of those errors come from and if there's anything that we can do to mitigate that. The next term that we need to talk about is the ballistic coefficient. Now, ballistic coefficient is a number that describes how efficient our bullet is as it penetrates through the air. So more efficient means it penetrates better. Now, there's a few terms or a few things that make up that bullet's ballistic coefficient. One of them is weight. The other one that we have is cross-sectional area. Another thing that's really, really important in that ballistic coefficient of the bullet is the form factor. Now, if you think about it, it makes sense. The form factor describes the shape of the bullet. So what we need to realize is that the manufacturer provides that number to us. It's on the box. It's in a reloading manual. That number is a good number to start with. Now, if we look at air density, we're going to boil our air density down to elevation and temperature. So we've talked about some of the inputs or some of the main variables that define our ballistic profile. Now, our ballistic profile is both our drop and our wind deflection. Now, drop is commonly referred to as trajectory, and this is due to gravity and air resistance. The bullet is accelerating towards the earth because of gravity about 32 feet per second, and that gives us that shape, that parabolic shape, or that trajectory. Now, in real conditions, we have to add atmosphere. We have to add air molecules that bullet's trying to penetrate through and get out of the way. We also need to know about the efficiency of our bullet, so we're going to add that ballistic coefficient number into our initial velocity. And what that implies is that our initial velocity is going to decay as that air resistance does work against our bullet, so it's going to change the shape of our trajectory. Okay, we've got a pretty good handle on the inputs and our ballistic profile, and specifically our trajectory. Now we need to understand how to compensate for that trajectory so that we can make corrections in the field and make accurate shots. Now, one way to do it is to hold our system up. So we've got a scope and we've got a rifle system here, and we've got some reticle right here, and we've got a crosshair in it. And if we don't have a ballistic reticle and it's just a standard reticle, we're just going to basically hold this whole system up, and it's going to elevate the rifle barrel so that that trajectory drops in on our target. Another way to do it is to calculate the angular correction required to adjust our rifle scope. And in this situation, we'll just adjust the scope by turning the turret, and if we need 12 minutes of angle to shoot 600 yards, it will raise that muzzle up 12 minutes of angle so that it impacts on our target at 600 yards. So there's a couple different options on how we correct for our calculated trajectory using our rifle systems. Wind deflection is the second component of our ballistic profile that we need to discuss. And usually it's quartering, whether it's towards us or away from us. And that wind quartering can be broke down into two component vectors. Basically, one that is parallel with our line of sight and one that's perpendicular to the line of sight. Now, that velocity vector, that crosswind velocity that's perpendicular to our line of sight, we need to compensate for that. It's just the same as trajectory. Either we can hold it in the scope or we can dial it on our adjustment. External ballistics is a very complicated topic. Now, we've discussed a lot of different things, from our input variables, ballistic coefficient, muzzle velocity, air density, to our calculated outputs for bullet drop or trajectory and our wind deflection. Now, what we need to understand is that it's actually very simple to use a ballistics program to put those inputs in and to calculate those outputs. And we also know how to make those adjustments for drop and wind, whether we dial or hold with a reticle.